All right, everyone. I think we're going to go ahead and get started here. So welcome. We're going to talk why Kubernetes on Azure today. My name is Gabe Monroy. I'm the lead program manager for Azure Containers. So I own Azure's container offerings, Kubernetes Service, Azure Container Instances, some other stuff we're going to be talking about today. I also have some other folks that are going to be joining me up in a little bit. Alessandro from Cloud-Based Solutions and Andy from Tigera are going to talk a little bit about some interesting stuff that we're doing with some partners in this space. But first thing I want to do though is I want to talk about the reason why you're all probably in this room. All right, containers are growing like crazy. Kubernetes usage on Azure has grown 10x over the last year. Our customers who are using this stuff have grown 5x over the last year. I mean, this is crazy, and really this is a reflection of what's happening in the industry right now, with really all of the different vendors, cloud providers, and everyone else sort of standardizing on container technology and Kubernetes as sort of an orchestrator to push that forward in sort of a vendor agnostic way. So this is pretty important, and again, I think this is probably a big reason why a lot of the folks are in the room here. So what I want to do is I'm going to cover a bunch of stuff today. Now, what I'm not going to cover is I'm not going to cover Containers 101, container orchestration, or sort of our general overall Azure container technology. That was covered in some earlier sessions. Instead, we're going to do a little bit of a deeper dive into some of the specific services that we offer, why they're interesting, and then we'll do a couple of interesting demos here. So first and foremost, I want to talk about Azure Kubernetes Service. This is really the centerpiece of, I think, what we're doing from a container orchestration standpoint, at least certainly from an open source container orchestration standpoint on Azure. Now, Kubernetes is obviously designed to make it really easy to run lots of different containers, right? So this is where you have many containers. Those containers need to talk to each other. They need to find each other. They need to load balance. You need to do canary deployments and health checking, and a lot of complexity involved with making sure that lots of containers can talk to each other. Turns out it's also complex to operate Kubernetes itself as a service, right? Lots of moving parts, lots of virtual machines to sort of herd. There's a data store called etcd behind the scenes that's tends to be very fragile and difficult to operate. So what we've done with Azure Kubernetes Service is we've delivered a fully managed experience for Kubernetes running on Azure. So what does that mean? It means you can focus on your containers, you can work with these open source APIs, and you can just kind of be a developer and not have to worry about this stuff. Fully managed, patched, automated, and if you saw the keynote with Scott Hanselman yesterday, you'll know that some really, really cool features around integrated monitoring, container health, and some really cool dev tooling that we're building with Azure Dev Spaces and things like that. Now, just to go a little bit deeper in here, this is all sitting on top of Azure infrastructure, right? Sitting on top of IaaS, right? There is VMs under the hood here. There is also Docker under the hood running individual containers. But you don't have to worry about that stuff as a consumer of this. All you need to do is, as an application architect or an infrastructure architect, submit these manifests into Kubernetes, and it's going to run your whatever you asked for, orchestrate your desired state, and get the job done for you. And then you also have these nice management features that I talked about before, where you can just sort of push button upgrade your cluster, push button scale your cluster, and really not have to worry about all of that tedious infrastructure management stuff, right? Now, how easy is it to get started with this? Well, this is using sort of the Azure CLI, but we've got equivalent experiences of the portal, which I'll talk about in a minute here. But AKS create, install the CLI, get credentials, you're done, right? Takes you about 10 minutes to get through the cluster creation using command line tooling, right? Then after that point, you're using kubectl, which is the command line tool for how you interact with Kubernetes to get nodes, and we'll do a little bit of that in a bit. Now, this is cool, right? This is good for day one. What's actually more important is day two, because really people are looking at this service to run production grade infrastructure on it. And what I always like to point out is this AZ-AKS upgrade command, or the upgrade box in the portal. That looks really simple, right? I'm glad it looks simple. It is actually simple for a user. Behind the scenes, this is extremely complicated. We have to do what's called a cordon and drain, which means that every time we upgrade a node, we have to add a new node that can handle the existing capacity. We have to mark the next node we're going to upgrade as unschedulable, which means cordon the node, so don't put any more containers on it. Then we have to drain the node, which means we gracefully send a signal to all the workloads on it so they can gracefully terminate. So if they're in the midst of processing a request, they can finish the request before they exit. And then after that, we insert the new node, remove the other one out of service, and we have to do that across the entire fleet of machines, right? And these clusters can be thousands of nodes in size. In fact, OpenAI, one of our customers talked about using a 2,500 node cluster on Azure. Right? Think about that, 2,500 nodes. Managing and orchestrating that is really difficult. We've turned it into one command. That's pretty powerful. So scaling equally simple, and we got some nice portal experiences for that. So one of the new things that we've announced at Build here is previously this has been all CLI focused. I happen to be a big CLI fan, but a lot of folks are looking for portal experiences for this. So we have really great portal create flow. You can go try that out right now. We have container health monitoring integrated and a lot of cool stuff. So I want to show you a pre-recorded video here of what this looks like to go ahead and create a cluster, and I'll explain some of the features here as we go. So first you're going to go to create a new resource in the portal, and you're going to find the Kubernetes service. And you fill out a resource group, all pretty standard stuff. After that, you're going to put in a Kubernetes cluster name. This is kind of the name that's going to show up in the resource view. A DNS prefix, that's how you're going to access the cluster over DNS. We now actually create a service principal. Previous to this, we did not. You can select your machine types, how many you want to scale. Now we also have this HTTP application routing feature, which is very, very cool. And the ability to support custom VNets. This is a big ask from folks. Not just custom VNets, but the ability to configure the network ranges that Kubernetes uses so you don't have overlapping network addresses. And we also have this Azure monitoring integration, which is on by default, which is what lights up all this very cool telemetry inside the portal blade. So after you hit create, this will run a final validation, submit this out to ARM for deployment. We also have a set of ARM APIs if you'd like to use this via ARM directly. And I've actually sped this up a bit because I don't think we want to wait for the 10 minutes for this thing to provision. But I mean, we could if you guys got want to sit and chat. But you'll see the deployment has now succeeded. And we can pop into the resource group here. You can see the My cluster that we just deployed. And you can see here upgrade, the ability to upgrade to newer versions. Now, obviously, at this point, we're running the latest version, so we can't really show an upgrade. But this is where you would go. You would get a notice that your cluster is out of date. For scaling, you can use the slider here to select as much scale as you want, hit save, and that's going to go trigger a growing or shrinking of the cluster. Now, interestingly, on shrink, we actually have to do that same cordon and drain to make sure we're looking after your workloads. And this is very cool. This is integrated into the portal, a view of all the containers and nodes that are running in your cluster, right? So you can drill fairly deep into right into the logs of everything that's running in your cluster, all from inside of the Azure portal, which is extremely useful. Great, and with that, I want to transition to another service that I think is really important. Now, this isn't directly related to Kubernetes, but you're going to see it's actually pretty important to be viewed as kind of part of the overall Kubernetes story. There's a product called Azure Container Instances, and what this is this is your container running in the cloud with no orchestration at all. It's micro-build, and it has no virtual machines associated with it at all. This is what we refer to in the industry as serverless containers. And interestingly, Azure was the first cloud provider to come out with serverless container offering. Amazon followed along later with something called Fargate. You may have heard the term Fargate get thrown around. So there's a big movement in the industry towards serverless containers and making sure that developers can leverage this as part of their overall container portfolio. So what is this? Is easily run containers with a single command is one way to look at it. You can use this right away. You can get cloud hyperscale capacity. And these are also hypervisor isolated. The case study we did when we launched the GA of this recently was with a company called Jadox, who is using ACI to isolate trial subscriptions for their software for customers, running trials inside of these ACI container groups. It was a really cost-effective way for them to scale their SaaS solution. Now, how you use this is very simple. AZ container create, name it, pass in the image, the resource group, whether you want a public or not, some other tunables, credentials for how you pull the image, how much CPU and memory you might want. But in general, that's it. You hit the web endpoint and the thing is done. It's running in the cloud. So this is really, really useful for running like a lift and shift based application, or actually more useful, it turns out, for doing batch processing. That when you launch a first of its kind service, you have an idea about how people might use it. It turns out that batch processing, leveraging the billing model, this per second billing model, turns out to be a really terrific use case for ACI. Now, with this, we also have a great portal experience, and let me show you a little bit about what this looks like. So again, we're going to go to the containers menu, and here we're going to specify the name of the container. Now, I could choose to make it a private image, in which case I would pull it from ACR with some credentials that would pop out there. But in this case, I'm just going to deploy IIS Nano Server into an existing resource group in US East. Now, as part of this, I'm going to select whether I want Windows or Linux. In this case, I want to deploy a Windows container. I'm going to name the container with a DNS label, so I have a static DNS endpoint that I can use to reference this thing. After that, I'm going to hit OK, deploy it. Now, this process takes anywhere between 10 and typically 30 seconds. For some of the larger images, it could be a little longer. It's mostly dependent on the image size. Now, once this is running, I can take a look at my IIS container. You'll get memory, CPU, graphs, that sort of thing. If you jump into the container logs, you can see that we're currently waiting for this thing to spin up. If we refresh here, you can see, oh, okay, the deployment finally succeeded. So if we hit refresh again, you can see that the container has now been started and is now running, right? So very, very simple portal experience to get this thing working. You can look at logs, look at events. But the more important thing you want to do is you want to grab the fully qualified domain name here and punch it into a browser and see, hey, there we go. Our IIS service is running. That was pretty straightforward, pretty simple. And you can really do that with any Linux container or any Windows container. Now, this isn't Kubernetes, but I want to paint a picture here of how we're going to draw the line between these two things. Now, when we launched this service, myself and my counterpart in engineering, Brendan Burns, who's actually the co-creator of Kubernetes, not sure if folks are aware of that, but the person who co-created Kubernetes works for Microsoft and is my counterpart in engineering, so we have some stuff to say about that. So when we were coming up with ACI, what we decided was we wanted to launch the virtual kubelet, or it was actually then called the ACI connector, in order to demonstrate that ACI was not intended to be a new orchestrator. It was not intended to compete with Kubernetes. And so to do that, we showed how we could use the two in combination, right? How do you get the benefits of Kubernetes with the benefits of a serverless container runtime, thereby equating to serverless Kubernetes, or Kubernetes without any VMs, where all your workloads are micro-built, right? So you got these rich orchestration capabilities with Kubernetes, infinite scale provided by ACI. How do we pull this together? Well, this is a little bit what it looks like. You have folks who are submitting manifests and containers to the Kubernetes control plane. You're invariably going to wind up with some waste as part of this, right? And wouldn't it be great if for things like your burst capacity, you weren't relying on statically provisioned resources, but instead you could install this virtual kubelet component and dispatch that burst capacity off to ACI, where it could be micro-built, and it would work alongside everything else. Now, if you didn't have ACI and the virtual kubelet installed, it would just work the normal portable Kubernetes way on the instances you have. But if you choose to schedule things over to the ACI via virtual kubelet, you can choose to do that, and everything still works portably, just with the benefits of serverless containers. So this is the bursting scenario, and folks are extremely excited about this. In fact, I just got back from KubeCon in Copenhagen last week, and I'm actually working directly with the whole industry, Amazon, VMware, companies like HyperSH, Alibaba Cloud just announced their use of virtual kubelet. Virtual kubelet even made its way into the keynote demo. The IoT Edge work is now using virtual kubelet to allow developers who want to target IoT Edge to write stuff in Kubernetes manifests and have that be driving IoT Hub. So a lot of interesting uses for this project. We're pretty excited about it. Now, the next thing I want to talk about is Azure Container Registry, right? Registries are for storing your container images. And like with anything, storage is typically the first thing you build when you're building an IT system. So it ends up being a pretty foundational component to the overall Kubernetes picture on Azure. Now, ACR allows you to manage a private Docker registry as a first-class Azure resource. So, familiar Docker tools, this is the destination you're going to Docker push your images to, whether you're doing that from your laptop or from some CI system like VSTS. And we also have this really cool feature called geo-replication. We are the only cloud provider who offers this. Now, I'm going to show you a demo of what this looks like because it's just super slick, right? This is an ACR view in the portal. If you click on the replications button, you can just select the geographies where you want your container images stored, right? So I'm in East US, but I have another cluster I need to manage in West Europe. So I'm just going to add West Europe to this thing. And I'm going to go ahead and wait for this to sort of submit, refresh. And what you're going to see in a moment is that we're actually going to be replicating all of your Docker images automatically behind the scenes into this new region. And what that means is that when you do a Docker pull, or Kubernetes does a Docker pull, wherever you are, it's going to pull from the closest copy of those replicas. Now, here's why that matters for Kubernetes. When you start dealing with Kubernetes at any kind of scale, you have to worry about failure modes, right? So what happens if you lose a fault domain and you have a bunch of virtual machines that kind of drop and all those containers get rescheduled to the rest of your fleet? Well, in that case, you're going to wind up with what we call in distributed systems a thundering herd problem, where all of the images are going to start to get pulled right away because you're recovering from a failure. Now, in that case, if you have geo-replication, your time to recovery is going to be a lot faster because you're going to be able to pull those image layers really quickly, and your containers are going to start up and get running very quickly. Now, if you were instead not using geo-replication, you'd be pulling over the WAN links, right, over the internet, potentially over oceans. And that's going to be extremely slow, and your time to recovery is going to suffer. So ACR geo-replication turns out to be pretty important of a feature, and I'm very happy that Azure is the first cloud to offer this service. So. Now, next thing I want to talk about here is the open service broker for Azure. And we're going to start to get a little bit more down into the weeds here. Now, open service broker for Azure starts from the premise of just because you can run something in a container doesn't mean you should, right? Things like data stores, right? Do you really want to run your production database in a container? Can you? Yeah, you definitely can. You can run it on AKS in a container. It works. We've got lots of customers doing that at scale. But oftentimes, the better bet is going to be to use one of these terrific SLA-backed services that we have, like Cosmos DB, or Azure Database for MySQL, or Azure Database for Postgres, right? These are great SLA-backed services, and why would you not use those and get the SLA from them versus having to run them and care and feed for them, running inside containers in Kubernetes? I mean, do you really want to hire not just database administrators to look after those services, but database administrators who are fluent in containers and Kubernetes, right? Pretty rare set of skills. You're going to need to do that effectively. Now, Open Service Broker for Azure allows you to bridge the world of Kubernetes and other platforms like it with the world of first-party services running on Azure. So how do you connect these Azure to Azure services and platforms from containers? This is a standard, industry standard protocol. So this actually came out of the Cloud Foundry ecosystem. And myself and some other folks at Deis, before we joined Microsoft, were very instrumental in helping bring this technology into the world of Kubernetes. What's cool about this is that it's actually, because it's a standard, it doesn't just work with Kubernetes. It actually works with OpenShift, Cloud Foundry, Service Fabric, Kubernetes, can all use this protocol to facilitate binding containers that are running inside these platforms to different Azure services in a standard uniform way that works across these platforms and also across different hosting environments. Now, to show how this works with Open Service Broker for Azure with Kubernetes, these are the two commands that you would typically need to run to get this thing working. I'm instead going to go flip over, and we're going to do a little bit of a live demonstration here. And I'm going to show you how this works. And we'll see if the demo gods are with us today. All right. So over to the command line. Now, for any of you who have not used Kubernetes at the command line, this command is really annoying to type 100 times. So the first thing you'll do if you're using a shell is you will type alias k equals that command, because it's just going to make my life a lot easier. So the first thing we're going to do is type kubectl get nodes. And let's see what we got here. Well, we have a 3-node AKS cluster running version 196. I actually provisioned this one last night. It's got all the new bells and whistles, but very, very easy to get running. Now, normally, actually, what I'm going to show here is I'm going to show installing WordPress. How many of you here are familiar with WordPress? Okay, yeah, it powers like a lot of the internet, a shocking amount of the internet. And if you know anything about WordPress, you'll know that it consists of a PHP front end and a MySQL server back end. Now, actually, let me install this now so you guys can see this go. So we're going to use Helm, which is the package manager for Kubernetes. We're going to type Helm install Azure WordPress, name WordPress, namespace WordPress. All right, so that thing's going to go do some stuff, and we're going to wait because it takes a minute. So if you're normally installing WordPress, you normally want to target WordPress for Kubernetes. You're going to have a PHP application container, and you're going to have a MySQL container, right? That's PHP MySQL is what makes up Postgres. Now, running that stuff on Kubernetes, yeah, you could do it, but if you're going to put that thing into production, you're probably going to want to swap the MySQL that's running a container for Azure database for MySQL. Now, that's exactly what this Helm installed package does, right? It actually includes something that we call a service instance and a service binding. These are concepts inside of the Kubernetes service catalog that allow you to provision and bind to different services running in Azure. So if we kubectl get service instance in namespace WordPress and output that to YAML, you can see that this is a big, sort of beefy output here. But what you can see is we've requested an Azure MySQL 5.7 with a service plan reference. We have some firewall rules specified. We want this in ECUS in the resource group WordPress. And the instance is being provisioned asynchronously is the current status of this thing. So if we actually flip into the portal, oh, I don't have my portal open. Let's fix that. So we go into our resource groups, we take a look at the WordPress, and we hit refresh. Well, it hasn't gone around to provision that yet, so let's give this a minute. Now, what will happen is, this thing will just kind of spin, waiting for the instance to get provisioned, into Postgres. Now, if we flip back up here, we can see what are the other things that were included in this package. Well, we included also a pod, which is the actual WordPress application. This is the PHP container that I was talking about. This is currently pending to run. Now, the reason why it's pending is because it's waiting for a Kubernetes secret to get populated. That secret is going to contain the connection string details for how to connect to the MySQL database. Now, normally, in a normal environment, you would be injecting this stuff by hand. Usually how this works is someone in the a developer is going to say, oh, hey, I need to connect to MySQL. Can you get me, provision one of those for me and give me a username and password? And operations team says, sure, and they provision something, they write the username and password on a piece of paper, and they walk it over, and developer tries to type it in, and they fat finger it, and it doesn't work, and I can't get connected, and you go back and forth 3 times, and eventually the thing comes up, and you're good until someone leaves the company, and you got to go do that whole dance again, right? Because you got to rotate the credentials, right? What we're doing here is through using the Open Service Broker, we're completely automating the provisioning and binding process to these services. At the end of this, we're going to get a WordPress that's running, but no one will have ever touched the username and password. In fact, they're going to be completely automatically generated, which facilitates things like rolling updates. So if we do another query of this, you can see still being provisioned asynchronously. But let's see if we can see it now. Well, here we go. We can see the database. Now, you'll notice that the database is actually, the name is a GUID, not extremely friendly. We have had folks ask for friendlier names. It does look like this thing is up and running at this point. You can see the database running. And let me show you the other bit of this, which is a concept called a service binding. Now, what the service binding does is it actually references a service instance. You can see up here, sorry, the spec is it references this WordPress MySQL instance that was part of the package that we installed. And what it's doing is it's targeting a secret name of WordPress MySQL secret. So what it's going to do is when that instance comes back and says, hey, I'm ready, I'm done provisioning, everything looks good, it's actually going to, the broker is going to go talk to the MySQL, grab a username and password and a database and inject that into this Kubernetes secret. But it can't do that until the service instance is provisioned. So we'll watch here and say it's still being provisioned asynchronously. Go back to this and see where we are. Okay, so status available. We have a server name, Azure username, general purpose. Looking good so far. Still being provisioned asynchronously. I'll wait for a moment. Now, I'll jump over to another screen and we'll take a look at the pods, kubectl get pods and namespace WordPress. And if we wait and watch on this pod, we can see create container config error. This is actually not going to come up until the secret is actually injected into this pod, as I mentioned before. I'll wait another minute. Service instance. Well, you know what? Let's let this run and we will come back to it in a moment. Okay, we'll come back to it in a minute. We'll let it spin. It likes to take its time. All right, so the next thing I want to chat about here is release automation tools. Now, one of the things that we take very seriously at Microsoft is the ability to empower developers who are trying to get productive with this technology. It's all great that the industry decided that Kubernetes is the next thing. But the meme right now in the industry is that Kubernetes is still too hard to use for developers. And really it is. It's actually a lot of surface area in the API and it's still extremely difficult. So we've actually been doing a lot of work in open source communities to build open source software that helps streamline this effort. Now, I came to Microsoft about a year ago as part of the Deis acquisition, and these are, this is something we took extremely seriously while we were at Deis. So one thing we built while we were there is the tool I was showing you before called Helm, and we also built some other stuff more recently, Draft and Brigade. Now, Helm, if you're not familiar with it, is the package manager for Kubernetes. Now, this is very similar to operating system package managers like Yum, if you're familiar with Red Hat, or apt, or Chocolatey, or things like that. This allows you to package up lots of different Kubernetes resources into one install command, like you just saw before with the Azure Postgres. This is an important building block because prior to this, Kubernetes had no way to associate groups of resources together that you could override with different configuration information. So it turns out that this is a pretty key part of the ecosystem. The next is a tool called Draft, and I'm going to have Alessandro up here in a minute to show awesome, cool stuff with Draft. But what Draft does is it simplifies what we call the inner loop of development for Kubernetes. The inner loop is while you're working on a piece of code, but before you're ready to commit and push that code to version control, right? How do developers actually work on software in a complex distributed system without having to do complete end loops of every change that they're deploying? Now, if you saw in the keynote yesterday, we have the Azure Dev Spaces product, which is incredibly slick and something you can only get on Azure. Now, that Dev Spaces product actually builds on the same sort of technology and formats that Draft uses. So Draft is really focused on how do we solve this in Kubernetes so that everyone can benefit from inner loop development, because Microsoft has a lot to contribute in this area. But we want to do it in a way that it works everywhere, right? So you could use this on an on-prem system or on your laptop or somewhere that's not Azure, right? But then we also pair that with something like Dev Spaces, which provides a unique, better on Azure experience, right? And that's really the best way to think about Draft and how it compares to Azure Dev Spaces. Lastly is Brigade, and Brigade is something that is not extremely, this is extremely early. It's not something you're likely to use today, but this is a problem that a lot of folks in the industry are trying to wrestle with. The idea is, Kubernetes deals with these manifests, these YAML manifests. You saw some of those while I was interacting with Kubernetes before. Not everything in the world can be expressed through a YAML manifest. Sometimes you need Turing-complete control flow. You need looping constructs. You need the ability to have concurrency primitives, right? How do you do that and yet also get the power of Kubernetes? Well, that's what Brigade does. It's a scripting language for Kubernetes. More specifically, it's a special customized JavaScript runtime that we built to run on top of Kubernetes that can actually call out to Kubernetes to perform things like pod executions that allow you to construct workflows inside of your cluster. Now, you can see here, this is a brigade.js file that runs in your repo. And what this particular one happens to be doing is on a push event, this happens to be a push from your version control system, be that VSTS, GitHub, whatever, run this JavaScript and then do some stuff in the cluster like build some containers or push some containers or run some tests, right? You got this great distributed system in Kubernetes, and yet a lot of people aren't using it yet for CI. So that's one of the things we're looking to solve with Brigade, again, in open source. So with that, I'd like to bring up Alessandro to talk about what we've done to bring Draft to Visual Studio, or more accurately, what Cloudbase has done to bring Draft to Visual Studio. Here you go. Thank you.
All right. So my company, Cloudbase Solution, does a lot of work related to interoperability, meaning bridging gaps between open source technologies and Microsoft technologies in our case. You might know us from everything Windows related in the OpenStack world, and now we are also involved a lot into Kubernetes, okay? So the area in which we are most involved is the porting of Kubernetes on Windows. So for example, you can find us typically on the SIG Windows channel in the Kubernetes Slack. And since we come also from a developer background, we were thinking, well, all this Kubernetes work comes typically from a Linux background. So it can be very familiar with people used to work on the command line, used to edit YAML files and everything else. Now, you need to understand how Docker files work, how the Kubernetes resources need to be edited, how to the Helm charts need to work, and how draft needs to be used for scaffolding, it might take a little bit. So we thought, what are developers in the Windows world usually employing? So how many of you guys are using Visual Studio? Good. No surprise. So what we did is an extension for Visual Studio that allows you to easily create, transform, let's say, any .NET application into a Kubernetes application, okay? Let's see how this works. To begin with, it's a Visual Studio extension, so if I look here in my extensions, I just find it over there, okay? Next, what you will typically do in your development lifecycle is to start with a project. So let's start with that. ASP.NET Web Core application. So right now I'm doing a ASP.NET Core, but it will also work with the full framework because, as I mentioned before, we also have Kubernetes on Windows coming, right? Actually, Kubernetes on Windows is already out in beta. So I'm creating my application. So nothing special here, just a regular .NET application. You see on the right all the files generated by the template. So nothing new so far, no? While if I do a right-click on the project, I click Add, and I say Kubernetes support. What this thing is doing is to call beneath the scenes, so understanding what type of project we have there, because it doesn't work only with .NET. It supports also Node.js, Python, and so on, okay? And it detects what type of project, and it will run draft create. So it uses the draft project mentioned before by Gabe to create all the scaffolding necessary for Kubernetes. You see on the right that I have a bunch of new files that showed up. For example, I have a Docker file here that came out of the blue, right? So no need to write it from scratch, it's there. This comes all for the so-called draft packs, okay? So draft has the knowledge of individual configurations, called packs in this case, for different type of projects, okay? The next thing, I can edit those things. I can decide, how my deployments have to be, how my Helm charts have to be configured and everything. When I'm done, I just right-click, and I say, deploy to Kubernetes. Now, before doing that, you see on the top, I have also a toolbar, which allows you to switch the Kubernetes context. For example, the demo that I'm going to do right now, which is a live demo, so crossing fingers for the demo gods, is going to use an AKS cluster, okay? So we're going to deploy with one click this entire application on AKS. And it's not finished. Or I could switch context and, for example, use my local Minikube or Kubernetes, a Kubernetes cluster running on any other cloud, on OpenStack on-premise, on Azure Stack, on VMware, whatever you prefer, okay? So deploy to Kubernetes, and I'm starting it. What's happening is that the first thing that we need to do here behind the scenes is to create a Docker image, okay? Which is what's actually happening right now. Basically, what's happening is that the Docker file is used to create the Docker image, which is, as you can see, separated in two parts, two stages. And then that Docker image gets pushed on an ACR container registry, so on Azure. And afterwards, Helm will be able to deploy the application itself, okay? When we are ready, so it will take a couple of minutes, when we are ready, we will also be able to connect to the application, okay? So I have a couple of minutes to explain how this full thing works. When you develop, you need also typically to connect a debugger. You need to connect to whatever port gets exposed by your applications, okay? Whatever services. So there are various ways of doing this. And if you're running on a public cloud like we're doing right now, it may be also a little bit tricky. So Draft has a great feature called Draft Connect. It allows you basically to create a port forwarding from your local development machine to whatever port you have exposed in your Kubernetes application, okay? In this case, we are going to have two of them. One of them is port 80, because, of course, we have a web application here. And another one, which is going to be forwarded on my local host on port 8080, okay, but that's configurable. And the second thing is port 22, because when you debug remotely .NET Core, you can do it basically on various options. One of them is to run SSH tunnel. To make that secure, before starting the deployment, we also generate a random SSH key, okay? So whenever you start a new deployment, you create a new image, you automatically have a new key, okay? So that's secure by design. Finish the first part, now it's pushing the image. So this stuff is going straight to ACR, okay? This should be relatively quickly. Afterwards, we have the Helm part. It's almost done. Oh, did I mention that this project is fully open source? It's called VS Kubernetes, github.com/cloudbase/VS Kubernetes, okay? It's a new project, of course. We are developing it. We are also going along with the updates that come with draft and everything. If you guys want to contribute, feel free, okay? We are a community. We like to work together. All right. Okay. Voila, finished. As you can see, everything is done. So I can go here, and I can just show you quickly. I can do an Helm list. This is on my Kubernetes cluster, okay? And you can see I have web application 1. It takes the name, of course, from the project. And it's deployed. And if I look at the pods, I have a replica set to 2, so I should find 2 of them. Yes, there is one already running, and the second one coming up right now, okay? So 2 different, basically, copies of the same container. So 2 containers running. Okay, now let's get to my favorite part. So here's my code in the application. I put a breakpoint, debug in Kubernetes. So what's happening is that we're running draft connect, and immediately afterwards, we are also attaching the Visual Studio debugger to that machine, to one of the containers which is running in the cloud, okay? So we are live debugging a container instance inside of Azure, okay? Not locally. Container is running. Sorry, the debugger is running. As I mentioned before, we get a port forward. So as you can see, web application 1 running locally. Running on Azure through a local port forward. And if I click About, voila, debugging live on Azure. Okay. Thank you. Okay, this finished my demo. Thanks, Gabe.
Great, thank you. Oops. So, thank you, Alessandro, for that. Let's go ahead and just switch back to this because I just looked at this thing. Actually did finally finish. So let's go ahead and just take a quick peek here at the pods that are running. And we can see that WordPress is now running. And if we get the service name from WordPress, we can see that we have an external IP that is now bound to this thing. And if I pump this into a browser, we can see the WordPress now finally running using Azure Database for MySQL instead of a container. So thank you for Demo Gods for allowing that to actually finally finish. So great. So what Alessandro showed is, I think, really interesting and really important. And I do want to tell the story about this a little bit. It's very important for Microsoft and the community at large to participate in these open source ecosystems. When we announced Draft before, it was primarily focused on Linux developers. And Alessandro and the folks at Cloudbase actually reached out to us and gave us a demo of Draft working inside of Visual Studio. And it was really all driven driven by them and that team. So incredibly, inspiring to see that kind of work being done, and I'm really thrilled to see that not just being completed, but also continue to get driven in the open source ecosystem. So, for us, this stuff really matters. At the end of the day, Microsoft is backing up what we are doing with these services, and backing that up with contributions to the open source community. We are one of the largest contributors to Kubernetes in terms of developer tooling, things like Helm, Draft, Brigade, to core Kubernetes itself, and to a whole host of other projects in the CNCF ecosystem. So this is, again, part of our ability to give back, especially around places like developer tooling, where Microsoft has a historical advantage. Now, next, I want to bring up Andy Randall from Tigera. Now, just to kind of set the stage here, one of the things that's interesting that changes in the world of Kubernetes is how you interact with networking. Containers are now so short-lived that you can't, things like IP address firewall rules just don't mean anything anymore. And so how you interact with that, this sort of new world, is extremely interesting. And to talk about that, I'd like to call up Andy Randall. Thanks, Andy.
Thanks, Gabe. And yeah, as Gabe was saying, this new world of containers really brings about some pretty fundamental and profound changes. And one of the biggest mistakes that I think you can make trying to conceptualize what containers do for you is to think of it as just a mini virtual machine, because it really does change in so many ways, particularly around just the dynamicity of this world. So if you think about, these are kind of real world numbers out of surveys that people are seeing of actual container deployments. An individual host is going to have at least 10 times as many workloads on it than it did in the VM days. And VMs in the real world, when they're orchestrated and dynamically spun up and spun down based on live criteria that are being automatically checked, are going to be churning at least 25 times shorter lifetime. And the net of this is that on a given host, on a given machine, you're going to have 250 times or more the churn on the network, the change in the number of IP endpoints coming and going. And you've got this massively increased or potentially increased attack surface area based on all of these additional endpoints that are now on your network. And so this is where the motivation for a lot of the thinking in the Kubernetes community has come from when we've tried to kind of rethink how do you do network security in this world where it's no longer a given IP address or a given subnet range defines an application. IPs are no longer meaningful in the Kubernetes world. So there's a few things that we kind of, stepping back, thought about as design principles or problems that we were trying to address. And the first one was we see a lot of people not necessarily massively redesigning applications to the whole microservice paradigm, but just picking up a traditional 3-tier application and dropping it in the cloud, and that'll be their starting point. So the first question they have is, how do I take that front-end app tier, database and tier, and just replicate that kind of security in the cloud when I'm putting these containers into Kubernetes? The next is tenant and namespace isolation. So Kubernetes has this concept of a namespace, so an isolation at the system call level of workloads to different users typically, but there's no guarantee of the separation at the network level. So we want to tie those together somehow. The third is as you start to take these traditional applications and break them into much finer-grained network mesh of communicating containers, how do you define a much more finer-grained microsegmentation policy around the potentially quite subtle interactions between containers? And then the last one is, once you've done all of this, how do you do this in a way that's going to be compliant, that your security team can come along and say, yes, I see how you're implementing security. Sure, it's not a traditional firewall, but this is going to check our boxes for us. So these are some of the things that we've been working to solve over the last couple of years. And as Gabe was saying, this has been very much a community effort. This is, we've put a lot of resources into it at Tigera, but the standard that has come out of the Kubernetes community for network policy, as it's known in Kubernetes, is very much driven by a whole host of players all coming together and saying, what's the right way to do this based on Kubernetes paradigms? So for those of you who aren't that familiar with Kubernetes, there's a few concepts that are very common across a lot of the application and deployment models that you have in this environment. And the first is this idea of everything in Kubernetes can have labels. So a label is just an arbitrary key value pair. And whether it's a pod or a namespace or a service, it can have labels applied to it. So we wanted to use this concept and leverage it as a foundational building block for network policy. So rather than defining the rules that apply to your application's connectivity in terms of IP addresses or subnets or all of these kind of network engineer jargon terms, we just reuse this concept that developers are using anyway to describe their applications. The second is, and again, this is very much kind of a Kubernetes paradigm or idiom, is it should be declarative. You shouldn't be typing in interactive commands that you have to run in the right kind of sequence. You should just describe what is the end state you want to get to and let the system take care of doing whatever it needs to go from the current state to the desired state. And then the third thing is this has to be super dynamic. So if you think about, Gabe mentioned, a user of AKS with 2,500 nodes, right? That's at that scale, when you're thinking about potentially each node having 50, 100 containers on it, you're talking about hundreds of thousands of pods across a Kubernetes deployment, each of which could be churning in a matter of seconds, right? So it's got to be hugely dynamic. And even when the container's not churning, those labels could be changing on the containers because these labels are actually very dynamic as well, or can be. So these are kind of the key objectives that we try to meet with Kubernetes network policy. So this is now an API feature of Kubernetes as of a couple of releases ago that became fully available and came out of beta. So I just want to take you through a quick example here of what this looks like, just so you can really see how simple this is. This is, it used to be, getting firewall rules implemented was kind of the domain of the network security engineer. This is now, we're bringing this into the domain of the application developer and empowering the application developer to describe the connectivity requirements that they have. So in this example, this is just super simple, right? But we have a front end that connects to a database over 6379 TCP connection. And we want to allow that connection because that's expected. Some other pod comes along and it has a labeled role helper, and that's its role. We don't want that to have access to the database because it's not meant to be connecting into the database. So this is what the policy looks like, and I'll just walk you through each of these elements. So the first piece, and actually before I do, this is a basic YAML file. So again, another kind of Kubernetes idiom. Everything is defined by a YAML resource. You apply this. So the way you would take this policy and apply it into Kubernetes is that magic kubectl command, kubectl apply, and then this YAML file. It's that simple. And every YAML file in Kubernetes has this kind of format where it defines the API version. So you can see this is a V1 Kubernetes API, and the kind tells Kubernetes what to do with it. Then each of these objects has some kind of metadata associated with it. In this case, we're going to give the policy a name, and we're going to apply it into a namespace. So the namespace is probably defines my tenant space that I'm working in. And then comes the important bit, the spec of the policy itself. And this is where the power of labels comes in. I have what's called a pod selector, again, a standard Kubernetes concept. It's essentially an arbitrary Boolean selection of pods based on labels. So this could be pretty complex. Here we're just saying select all of the pods which match role equals DB. So we're selecting all of these database pods, and then we're saying I want an ingress rule, so allow inbound traffic into all of those pods that comes from anything with the label role equals front end and restrict that to TCP port 6379. So super simple. It's easy to see how you can define this in the process of creating your application. Now you can extend this with egress policies, with other kinds of selectors, but the concept is basically the same. So this is part of the Kubernetes API set, but in terms of actually implementing it, Kubernetes doesn't come with a built-in implementation of this policy because it kind of depends on how you want to do your networking as to what the right way of implementing this policy is going to be. So one of the things that a networking plugin will typically have is a network policy controller, plugs into Kubernetes, and listens for these API objects to get applied into the Kubernetes cluster. So just so happens, the leading technology for this is a open source project called Calico, which my company Tigera founded and is the main contributor to. But it's actually a broad and well-adopted project, so there are hundreds of contributors across the industry participating in this because it has such wide adoption. And it really is known as, why has it got such wide adoption? For kind of the level of reliability and performance. I mean, I mentioned some of the challenges of scaling up to very, very large scales, thousands of pods, thousands of nodes, hundreds of thousands of pods. If you imagine any time a new pod is created or a label is applied, you have to recalculate all of those policies across every single pod, across the entire cluster. There's some pretty heavy scale challenges involved in that. And we've demonstrated and test up to those kind of scales. And also, my company does provide enterprise solutions that extend on Calico and build on this. So one of the things I've been really pleased about is the collaboration we've had with Microsoft, actually going back over the last 12 plus months in a number of areas. So the first is the ACS engine, which is like the open source core behind the Azure Container Service. We've had Calico integrated into there as a sole policy provider option for probably over 12 months now. We implemented a bunch of sample Helm charts. So you saw the Helm tool. You can go and find these. It's basically examples for some common applications. Here's how you might like to define policies around them. And one of the things we're talking about today is that we're announcing that we're implementing network policy as a first-class citizen capability within the Azure Kubernetes service. So that screen that you saw where Gabe created a new cluster and you got to choose what networking options you wanted. Did you want to put in a new VNet? There will be a checkbox in there, and do you want to have network policy available, which will from Calico. One of the other things we've been working on as well as with the Windows team within Microsoft is on a Windows port of Calico. There's a beta of this available right now. You can go get that in the Calico repo, running on the latest Windows Server container networking capabilities. So pretty excited about all of these things, I think, and you kind of put this all together and it says there's a really tight partnership here. One of the nice things about Calico is, in addition to the fact that it integrates well with AKS and you're going to get it out of the box there, is we see a lot of customers who are looking to do hybrid deployments where maybe they're keeping some applications still on-premise and starting to move them into the cloud. And that's one of the advantages of using network policy and using Calico policies is that those same network rules can apply in multiple locations. So it's, as opposed to the Azure Network Security Group, say, which are going to apply just in Azure, the same set of policies, you can pick them up, drop them into your on-prem Kubernetes cluster. Calico works with all the other clouds, because it's compatible open source, so you can drop it into other clouds as well. But we really think this kind of hybrid experience between AKS and deploying on-prem is going to be super popular. We don't just stop at Calico, though. We also have an enterprise product called Tigera CNX, and this is something we will be integrating with AKS as well as an option. And that adds a whole set of capabilities to the base network policy functionality. So if you want to have hierarchical policies, so your security team can define a set of rules which developers can't override, that'll always have precedence, that's RBAC controlled, where you have auditing and monitoring and troubleshooting and alerting and all of these kind of things that you need for enterprise-grade compliance. So those are the kind of things that we're going to be doing in CNX and making available on AKS. So, thank you.
Thank you so much, Andy. And yeah, I think it's really just terrific to see, how a lot of these old concepts around how do we secure network connectivity, right? Really basic things, how these look in the world of modern container-based distributed systems. I actually think there's a ton of advantages to being able to empower developers to express, through like the YAML-based language that, Andy was laying out here, how to express, an application needs to connect to these things. Because oftentimes the operations and security teams who are in charge of these, securing these workloads don't necessarily understand the connectivity requirements. So I'm really excited about getting this integration landed into AKS, and then also what Tigera's CNX can provide on top of that. So to wrap up here, before we get to Q&A, and I do hope you all have some questions for us here, I just want to talk about a few examples of customers who are extremely successful with Kubernetes on Azure. I mentioned before, we have OpenAI running clusters at massive scale here, but Ambit Energy is another one in the energy business, and they've done a lot of interesting things, not just with our Kubernetes service, but with a suite of other products. Another one is Siemens. I believe it's Healthineers is the name of the customer. We did a pretty interesting video on how they're using Kubernetes and container technology to really advance in the healthcare business. So a few interesting customer case studies to call out. And then lastly, on getting started, you can learn more at akka.ms Kubernetes build 2018 on this link. Here we're going to be sharing not just links to other sessions, but also my personal email, because I do want you, if you folks have questions, I want you to feel free to reach out to me direct. So. Lastly, if you could, please make sure you complete your evaluations, win some speaker prizes, win some prizes, things like that. Great. And so with that, I'd like to open it up to the audience for questions. We do have, it looks like, some microphones here. So who's going to be the brave first? Yeah, all right. We already got. Anyone? Someone's got to have a question. Yeah. Yep. So the question is, does AKS come with the service broker, or is that something you need to install after the fact? Right now, it does not come with AKS. The intention is to integrate it completely. However, this is technology that's still a little early stage. This isn't fully baked yet. As you can tell, the user experiences, we need to get a little bit more polished, graphical experiences, that sort of thing. But it's coming very soon. The demand for this from large enterprise is tremendous because people want to use containers, but they want the SLA-backed services too. Yes?
The AKS to ACI, that virtual you're talking about, how do you set that? Control it through the portal? How's that configured?
So the question is, how is virtual kubelet, the AKS to ACI connection configured? So right now, to be clear, the virtual kubelet is still experimental. We're still in the process of working with VMware, Amazon, Hyper.sh, Alibaba to figure out exactly what does the world of serverless Kubernetes need to look like. A lot of unanswered questions here. And just like Andy and company had to go through this exercise on how do we define network policy in Kubernetes in a multi-vendor way, we have to do the same thing with Kubernetes, serverless Kubernetes, and it's going to take a little while. But for now, you can play with it. You can install it. It's all available, and we do have some folks who are using this in production. Of course, people always figure a way to use stuff that's too early in production. Yes? The question is, what are some of the limitations of using something like Istio with AKS? If you're not familiar with Istio, Istio is something that's called service mesh technology. It's the idea of smart pipes, a smart networking layer, policy-based networking layer. You can actually use Istio with AKS today. In fact, the DevSpaces product that we use doesn't use Istio, but uses very similar technology, Envoy in particular. So all available today.
And I'll just add to that, Calico also integrates with Istio, so you can enforce Calico policies as well as being enforced on the host network level will be applied within the Istio service mesh as well.
Other questions?
Yeah, when you created the AKS that had a service principal, which presumably had a secret, that secret's going to rotate in a year. How can you rotate that without having to recreate the cluster?
That's a really good question. Right now, you still, this is sort of a known problem, and we're working around some mitigations for it. The future here is MSI, right? Getting to MSI is going to make this problem go away. And so the team is focused both on making sure that we don't have service principal expiry as an issue, and then also on how do we mitigate this, on sort of.
Sorry, what's MSI?
Sorry, MSI, another acronym. I figure everyone knows the acronyms. MSI is Managed Service Identity. It's a way of, making, it's sort of a different concept, a first-class identity concept for services to use inside of Azure.
Thanks.
Yep. Other questions? Yes.
So can you
apply the network policies to backing services as well?
Not today, but it's something we're looking at. So you can, if you have fixed IP ranges for them, you can create network sets and then apply labels to them. So they appear to have a set of labels applied to them, but not where those endpoints are dynamic at the moment. But that's something we're working on.
Yep, and there is ways that you could actually modify a broker to configure network policy. One of the things that we see a lot of larger enterprises doing is writing custom brokers that will, only allow certain types of, for example, you can't use MySQL. You can only use small sizes of MySQL, limiting the plan surface, but also being able to configure network policy as part of the broker logic and configure NSGs or different rules inside of Azure. Other questions? Yep.
Is there any integration, like in the future, like app service, like if you're running container-based app service, could we expect in the future, like if you already have an AKS cluster, instead of using like maybe a brand new set of VMs, to be like expect to see some sort of integration from app service to AKS?
So I guess the question is, can we expect some integration between app service and AKS? I would say app service is, probably not, I think, but app service is extremely useful if you're just deploying and managing web applications. One of the things that you could probably tell from this demo is that Kubernetes is fairly complicated. Right? It's a lot of surface, these different types of YAML descriptors are, can get pretty gnarly. And if you don't need that complexity, you should choose something more simple. App service is a good thing to look at. ACI, Azure Container Instances, is another. And we have other services inside Azure that could potentially be good fits as well. But yeah, I really view app service as a separate service from AKS, which is really focused on container orchestration versus app services focused on sort of getting up and running with web apps.
Yeah, I agree. Specifically talking about the containable support and how you can run your application.
Yeah, and app service support in containers, yes, understood. And I guess what I would say is that if you're confused by all the different container services that are running on Azure, I understand, but it's also important to remember that containers are just the new VM in a lot of ways. And so it's expected that we're going to have containers across Azure's portfolio. Everything's going to need to support containers, right? As far as what I think the more important question is not, if I have a container, what do I use? But what are you doing with the container, right? Because if you're running function-based execution, Azure Functions has a great container story as well, right? If you're running web apps, app service, simple web apps, app service has a great story. If you need to do complex container-to-container communication and derive the need for container orchestration. Kubernetes is great. And lastly, if you're writing .NET apps and you want to deploy .NET apps at scale, Service Fabric might be the great solution. I mean, those are the folks who wrote CLR, and they also do containers. So lots of different options for containers, and that is, I would say, at some level by design.
So will there be more sessions about Draft and Brigade?
More sessions about Draft and Brigade. Yeah, I believe there are a few other sessions about Draft and Brigade. I think there is a session focused on developer tooling at the show. But there's a lot here at the show, and feel free to jump by our booth, at the Azure Kubernetes Service booth and the ACI booth. We're happy to talk to you there as well. Sorry? When would you say that is a better candidate? When would you want to use AKS? I think if you're looking to do, the first question is whether you need container orchestration or not, right? If you need container orchestration, containers talking to containers, service discovery, load balancing, canary deployments, labeling, all that stuff, then that's one hint. And then the other is if you're looking to bet on sort of what's emerged as the industry standard, right? Kubernetes isn't just Microsoft, but Amazon, Google, or IBM, Oracle are all announcing managed services, managed Kubernetes services. So that means with that comes a lot of developers and operations folks who are going to get trained up on this set of technology. And so if that is important to you, kind of aligning with industry trends, and you need container orchestration and the complexity, then I think AKS is the right fit. Alessandro, any thoughts from you on that one?
Well, it's a big topic. I mean, we could probably go on quite a while on this. But yes, so AKS on Azure is just the way to go at the moment. So if you want to go with orchestration and containers and everything, so that's at least my personal recommendation.
Yep. Good. Are there any plans for kubeLego? Actually, so let me flip over here. So if you're not familiar, kubeLego, how many people here are familiar with a project called Let's Encrypt? Oh, wow, okay, that's a big number of hands. So what kubeLego does is it provides automatic TLS configuration and certificates for applications. There's a project called kubeLego where if you install it into your Kubernetes cluster, you magically get TLS certificates for all of your applications. We just recently, so for this cluster here that I'm running, I installed, we have this new HTTP application routing feature that I think I showed in the overview. That installs what's called an ingress controller into Kubernetes. This happens to be an Nginx-based way to expose your containers to the internet, to the public internet. This Nginx controller supports kubeLego out of the box today. So you could just install kubeLego on your AKS cluster that uses this integrated HTTP application routing. Actually, if we take a look at the containers, in here, you can see this add-on HTTP application routing that's running. So this is literally just the Nginx ingress controller, slightly customized for Azure, and it works out of the box with Let's Encrypt and kubeLego. ACI, no. It's a good question. Can you do container TLS with ACI? No. Right now you would have to bundle the certificate into the container image, which is not really ideal, but may work. Yeah, so if you're going to expose your applications with AKS, you're going to need to install an ingress controller. Now, we have this ingress feature, this HTTP application routing feature that will do that for you. So that means that, just like the manifest that Andy showed before, that his was a network policy, there is an ingress resource that basically specifies how you want your app to be exposed to the internet. That will just work if you select the HTTP application controller. this kubelego project will give you TLS termination for free for as many applications as you want on your cluster using the Let's Encrypt project, which is pretty crazy, thinking like about how we used to do TLS like even like 3 years ago. Now it's all free. Yep. Always someone who knows the details. Yes, the kubeLego project has actually been deprecated, or is in the process of being deprecated and being replaced with a new project called Cert Manager that does the same thing. Cert Manager, you know, kubeLego is dead. Long live Cert Manager. You know the deal. Other questions? Yep. Yeah, Windows containers and hybrid worker nodes. So we just announced, actually as part of the announcements at Build, a private preview of Windows container, Windows node pools with AKS. You can do this today, though, using the ACS Engine project, which is basically a way to get a unmanaged IaaS-based Kubernetes on Azure. You can actually supports Windows containers today. That was some of the work Andy was referencing. But that's going to be coming to AKS relatively soon.
It's worth also probably adding that the CI for Kubernetes on Windows is actually using ACS service. So all the information about how to run it and everything can be available simply by looking also at the projects in the GitHub Kubernetes world.
All right, got time for one last question. Yes.
I don't know if this is on. Any news about secret management in Kubernetes and integration with Key Vault?
Any news about secret management? Yes, some great news actually. In Kubernetes 1.10, we, the community, landed pluggable secret storage backends. And there are some videos available, and if you come by the booth, I can get you access to this. But we do actually support secrets persistence via Key Vault. It's coming to AKS very soon. We first needed the Kubernetes community to figure out how to do this in kind of a generic way. I will say, though, that secrets management is a lot harder than just persistence in Key Vault. There's a whole operational security lifecycle around it, and I would say it's safe to say we're pretty far from solving the entire problem, but I'm optimistic that folks from the community like Andy and Alessandro and others can all put our heads together and get a good answer that's going to satisfy everyone. So, all right, that's it. Thank you, everyone.